Okay, hello. I haven't done a recording in an extremely long time. And what I plan to do today is to implement this thing I did a while back. So basically a very simple hash table implementation, porting it to Golang, to Go. Um, I'm not going to go over a lot of the inner detail of this because I already basically did another like live basically session where I implemented a hash table from scratch in Python, and now I want to port it to Go. Um, so let's see how long this takes. Depends how hungry I get. I may, might have to pause the video. Um, but yeah, so let's get started. I already have here my folder here. It's gonna be called Go Lookup for the time being. Yeah, so let's start. I mean, I haven't programmed in Go for a while, so I might forget some stuff. And in fact, I'm gonna open, I think, the language reference. So Go of Golang. Okay, so I think this will be useful. Um, nice. So cool. Nice. So let's get started. Oops. Okay, cool. So the first thing I want to do is a hello world. So let's say touch main go. Uh, main go. Perfect. So is it package? I think package main. Oop. Okay, and then it's func main. What is it? And then import fmt. Okay, import fmt. And let's say fmt dot print line hello world. Okay. So now I have to run this thing. So I think I have to go like go init module. Go init mod. Okay, that's weird. So let me see. It's not go init mod. Okay. Go. I'm just gonna see what it will error out maybe. Yeah, so go. Okay. Go help modules. Okay, another thing. So let's go here. So go init module. Go mod init. There it is. Go mod init. Oh yeah, in my thing. So okay. So I think for now go mod init and let's call it lookup. Huh? Okay, cool. So yeah, it should already be existed here. Cool. Nice. So now I can say go run to compile. Go lookup is not a main package. Ah, it says package make. No, I don't know why it says main. I think. There it is. Hello world. Perfect. So that is that. So I'm gonna start here the hash table.go. Perfect. hash table. Okay. So when I close this off, look at here. So, okay, so I have this stuff here. So is the read size up or read size down threshold? So I'm going to say const read size up read size up threshold float 32. So something seems not happy here. Yeah, package. So I don't know. This probably package main as well because I don't have any. I'm having everything in the same folder. Okay, it's unused. Okay, so now I have const okay, so float 32 and 0.2, 0.12, and I think I'm gonna cut capital this as well. Okay, cool. Now this data thing. So I'm gonna create a struct for the time being. Well, not for the time being, but I'm gonna create basically a struct, which is gonna represent this. And basically, this class just holds the key, the value, and basically a boolean if it was like soft deleted or not. And that's the actual data that's stored in the hash table. So now I'm gonna try to remember. So type is it type struct data? Is it? See if it's struct type data or struct data. I'm guessing here. Type. Nope. Let me see if I have here structs. Struct types. Not quite what I'm looking for. So I forgot the combination. So let's do Golang struct. Okay, fine. Type person struct. Okay, so type. Okay, struct. Fine. Thank you. I'm gonna close this off. And so now I'm gonna have key. So in my Python implementation, I had these as any, so it can accept any value for the key and the value, so any basically data type. But I think for this one, I want to do, I think the key as a string. So key string, and then I'm gonna have so value and I think it's also any. Yeah, to interface in always. Okay. So any type of value and a bool. So soft is soft deleted. Okay, perfect. So now I have my stuff. Okay. I think that's fine for now. And now I have my thing here, my lookup thing. So it's also gonna be a struct. So I'm just gonna call it hash hash table struct, and it's gonna have a length. So length, and this is going to be a unsigned integer 64. And just to check something here, so UN64. I want to check the sizes. Size in bytes, yeah. So it's going to be 8 bytes. Unsigned integer 64. Perfect. So okay. Just curious. Bool should be. The bool should also be. I mean, it's gonna be Boolean size. I guess it should be 1 byte as well. Size. I don't know. Well, let's do something. So Golang bool size bytes. Why? Well, I don't know. Let's leave it like that for now. Who cares? Let's say it's just 1 byte. I was just curious. Okay. And then we have this thing called slots. So the slot is just basically an array. Just basically an array where each index is basically the hash key computed. So the hash value computed for the key. So okay. No. So, yeah. So I have the slots here. So let me see. Okay. I'm not sure how I'm gonna do that. Okay. Let me have a thing for now. So I'm gonna for now say active slot counter, and it's gonna be also inside into 64 and occupied UN64. Okay. So now what I want to do here is create the function to create the hash table. So I'm just gonna call it new for now, and I think the syntax should be hash table, and it's gonna create hash table, and it should return a hash table, and maybe this will have the length, like a length perhaps, and it's gonna be this, and length. Actually, I'm not sure if this will. No. This no, sorry, it's not gonna have this because it's not an instance method. So this should return Okay. So length, and then I'm gonna say, and then the rest should be false, so I don't have to. I know, sorry, active slot. I mean, I guess it by default will initialize at 0. I'm just gonna just put it here at 0 manually. Okay, so this should return this new hash table. I was thinking if it should return a memory address of this, probably. So it should return a pointer to the hash table, meaning the memory address of where that thing will be stored. And here, yeah, I think that's fine for now. And I'm not really sure if this will basically complain. Okay, so let me run just hello world again. Ah, shit. Okay, cool. So didn't go run. Okay, cool. So that's working fine. So now I'm gonna basically remove that hello world. Okay, so do something here. New and then 10. Okay. So now I can see that I'm gonna basically update my hello world. So and then decimal and okay, updated hello world. There it is. Okay, actually, length 10. There's one thing that I always forget, and this is basically the formatting, right? Like this stuff. So Golang, and I think it should be this, the official thing, and yeah, floating point. Yep, base 10, here it is. So that's why. Yeah, nice. Okay, cool. So I'm just gonna keep that open here just in case. Okay, now what I want to do is like I want to do the following. So just to test because this should update. So length equals 20. Okay, yeah, nice. Okay, perfect. Yeah, of course, because basically, like for that to work is because I'm returning the memory address of the thing, so it's operating on the same data, right? Okay. So now I can basically remove this. Okay. Cool. Now func new. Okay. Now I'm gonna implement this thing, the basically the hash function, and this is using Python's like hash by definition. So Python's hash is by default cryptographic. So it's like to hash, for example, it's like a secure hashing, like for passwords and all of that stuff. But for hash table, there is no need to do that because like we're not, like the computed hash of a given key doesn't need to be like secure. That will also speed up that calculation. So I think I could have also done the same here for in the Python version, but yeah, I think I didn't do it. I don't remember why. Maybe just for simplicity, but that's something I can basically change here. So I'm gonna basically do the same thing. So for now, I'm gonna make it public and hash table. Okay. So there is this thing here. So as Golang non-cryptographic. Yep. So Golang. Okay, perfect. So this is the seems like from the standard library non-cryptographic hash functions. Well, not sure if it's from the standard. I think it is. Glenn. Okay, it's the same one. Glenn Fowler. 64-bit out in big Indian byte order. There's no examples. I'm gonna check out this one. Mm, documentation, maybe. I think this is the documentation, perhaps. Yeah. Okay. So I'm gonna keep this here. I don't know if this one. Um, okay, so let me try something. Okay, so this is gonna have the. Oops, I think it's more like this hash and key string. So is it this one? Import hash. Doesn't really show any examples actually. Let me see this one. No, but I don't think it's this one. Because it looks like it's importing like a SHA-256. Some 64. Let's see here. Some 64. Well, I'm gonna try. Let me see. So Right. Um, right. So it wants a binary. And how can I convert the string? Now I need to convert this string to a binary. So let me see. How can I do that? So Golang convert string to byte array. Let's see. Okay, seems like this. So okay, cool. Okay, so I think I am not using this thing correctly. So let me see. So let me see if I can get some examples. So oh, okay. So import hash fnv. Fine. So new 64 perhaps. Okay, new 64. And then here I have hash dot right, and this should be here. Perfect. Nice. And then hash dot sum. So that should return, and I think this returns a UN64. Yeah. Okay, UN64. Okay, nice. I think I can do that. Okay. So now I'm gonna update the hello world. So let me say hash and then I'm gonna say food. I don't know, for one, whatever it is. Okay, cool. That's working. Should return, of course, the same hash. Nice. Okay, so what I basically have, so I'm gonna basically close this. Maybe keep these ones open. So now basically what I did is this here. This basically this line here is this. So cool. So let me have this. I'm just gonna actually just call it f and v hash. Okay. Of course, I don't have to. Now I'm gonna just uncomment this and comment it out for the time being. Keep it with old hello world. Okay. It's probably complaining that it's not being used. Yep. Okay. Cool. So now let's do the rest. So this is like a custom hash collision also handler. So it first calculates the hash key, then it calculates like a second hash, then let's say a third hash, and then after that it returns the final hash, taking into account these two, the collision count, and then at the end it does, of course, modulo length, so it's between, so the final number is between the actual size of the hash table itself, so we don't have index out of bounds. And this basically hashing technique is based on integer universe assumption using hashing by division technique. So basically that's the type of hashing that's done. So so let's again go. So P, and then this is also gonna be doing 64. Okay, perfect. So now we're gonna have the hash key here, and we're gonna call our FMV hash. Okay. Then hash 1. Length. And then hash 2. Hash key modulo h.length minus 1. And here we return the final one. So it's hash 1 collision count, which I need to define, times hash 2 modulo h.length. Okay. Why is this complaining? What do you mean it's unused? Not sure. Not sure why it's complaining. But okay, so this is it. This is it. And okay, so now I'm gonna go back to hello world. Okay, so now let's do a hash. And this needs collision count, so I'm gonna say 0. Oh, okay. Now this should work. There it is, 3, and it should be the same. Perfect. Now let's say if I put collision, let's say there was one collision, it should be a different index. Ah, there it is, perfect, different index. and I'm gonna say like foo2. There it is. So foo2 also has index of 4. So let's say foo3. Nice, perfect. So it seems, yeah, it's working nicely. Okay, cool. Nice. So the other thing then I'm gonna do here is the load factor. And that's basically that little formula here. So it's the load factor equals the occupied slot counter divided by the actual length. So basically here, this occupied slot counter keeps track of all occupied slots, both active and things that have been basically soft deleted. So things, basically when you delete items in a hash table, they're not removed immediately, they're soft deleted. That means that they're only basically removed once the thing is resized up or down, like when it has to grow or shrink. And then these ones are actually the ones that are not soft deleted, so the ones that are actually considered as active. Okay, so okay, so here memory address to the thing, compute. There's actually, yeah, okay, one thing, okay, factor, and then this will return, let's, I think, probably float, not really sure. Yeah, float, yeah, actually it has to be float 32, we can handle those. And then we can say oh yeah, of course. I have to cast it here because occupied is an integer. Yeah. Divided by float 32. Yeah, h dot length. Yeah. I think that's how it should be. Yeah. Okay. Nice. So I think that is it. Compute load factor. Fine. Boom. Okay. So now one thing, yeah, that I wanted to do is go back to this part, the slots. Um, so I think no. Wait, before doing that, I'm gonna basically go here. So slots, and that's the thing. So hmm, so I think for now, one thing I'm gonna do is have like an array of pointers to those data objects, and I think that is the correct. Let's see. Let's see why it's complaining. No. Ah, okay, yeah. Missing this thing here. Still complaining. Like also need it here perhaps. No, kind of guessing here now. It's not like that. So something I'm not declaring here, right? But basically, I'll check that a little later. But what I'm trying to do here, which I don't think is going to be very efficient, um, but I'm going to leave it here for now. So paint. Okay, so I'm going to open here paint. And then, I hate drawing with a stupid mouse. But basically, what's going to happen here, if I have an array of pointers, so and I don't know if I can lets me draw straight lines. Yes, yeah, nice. So let's say this is the array, okay? And why doesn't it let me draw straight vertical lines? Anyway, so let's say this is the array, right? The slots array. Okay, slots array. Oh, come on. Cool. Yeah, nice. This is really crappy. What is this? Doesn't let me move it? What? This is ridiculous. Let me see. Yeah, what a crappy thing. This is crazy. What? Oh my god. Okay, and I have here a dog with me as well. And he's always sometimes very needy. Taking care of him. He's a friend's dog. Okay, Sunny, I'm recording. Down. Down, Sunny. Good boy. Stay. Okay. Okay, fine. So I don't have to write it. So this is the slots, all right? So basically what's going to happen here, so I'm going to have some address, some memory address, right? So I'm like, whatever, it's represented like OX or whatever it is, right? Right? Some address here, some address here, some address here, some address here, some address here. And essentially, these will be the memory addresses of where actually these data structs are stored in memory, the actual data, right? So that will basically be, those things will be somewhere, somewhere in the heap, right? So if I draw a heap, kind of like some diagram of that. So if I'm gonna represent it just diagrammatically as something like array of boxes. Why isn't this shit drawing straight anymore? Whatever. Right, so let's say something like that, like this, like that. So these things will actually point to the actual like locations where those things are stored, right? Here, but then they can be like in different places, right? All over the place. So this memory address is here. Then, for example, this memory address is here. This memory address is here. This memory address is here, and so forth. So this will basically create different this will be quite inefficient, I would say, because every time we have to like go to the actual data, we have to do like an extra hop, one hop to go here. No, this also has its own like memory address as well. This thing has also its own memory address, right? This little thing. So we have, this basically, you have to go one hop here plus another hop here, right? So in total of two hops, to actually fetch the data, right, from where it's stored in memory. And I think that could be quite inefficient if we want to do, right, if, for example, this is like, yeah, it's going to be quite inefficient for any operation, like searching and deleting, and perhaps insertion as well. And I think that will also cause like potentially some cache misses as well, more potential for cache misses. So I'm gonna just do that for the time being, and later it would be interesting maybe to see if on benchmarking this versus, like, let's say the other option is we have our slots array, and then we actually store the actual like data, right? So they won't be pointers. They won't be pointers to the data, but they will actually store the same stuff, right? The actual data. And I think that will basically, of course, they will be laid out sequentially in memory, and we don't have to do so much of those hops. We will have, like, we'll also benefit from data locality, and that will also allow us to not have so many cache misses. So I think that's the thing, right? But I'm gonna do the pointer thing at the moment. Yeah, but this doesn't really need that. I mean, there's other data structures, for example, like the linked lists, where you're actually kind of forced to implement it, kind of like this, pointers to the data. But in this case, since we're just dealing with an array as such, yeah. But let's go for this option first. Let's see. Um, nice. Okay. So I think I'm gonna, just for the expediency, I like to use perplexity. So I'm gonna say create a struct which has an array of another struct as a property. I don't know. Let's see if it understands. Okay. Mm, you know what? I'm just gonna go and say fix. Cheating actually, but it just to make things quicker. Fix. No, I want a pointer to us. No, I want a pointer to. So pointers to data. Okay. Okay, it's interesting. This is like this. Okay. I want to see if I can get away No, I can't get away like this. Can I get away like that? What is this? Okay, so let's see what this says. Here you can adjust your code. To store pointers to data in its slots rather than the actual data object, you should change the slots field to be a slice of pointers. Okay. This is a common pattern when you want to efficiently manage large objects, avoid unnecessary copying or share objects between different parts of your program. This approach allows each slot to store a pointer to a data object or null if the slot is empty. Yep. When you insert a data object, you assign its address to the appropriate blah blah blah. Okay, fine. So yeah, it seems like I need to do this make thing. It's like to initialize the slice, I believe. So make and length. Okay, nice. So that seems to the make built-in function allocates and initializes an object of type slice mapper only like new. The first argument is a type, not a value. Unlike new, makes return type is the same as the type of its arguments, not a pointer to it. Okay. So what I want to do now is say slots. I want to print this out. And this should be, see if it's pointer here. Okay. So that's the pointer to so that's the memory address of that slots array. But I want to see, let me see. So, okay, maybe without format. Let me see how it does by default. Okay, yeah, this is what I wanted to get. So yeah, basically this is it. So we should have 10, of course. And of course, everything is nil. So the default value for a Go pointer is nil, right? So let me see if we can find here nil. I'm looking. Sorry, I'm looking through this thing here. Actually, that's stupid. I wanted to do here nil. A pointer type denotes a set of all pointers to variables. Blah blah blah. The value of an initialized pointer is nil. Yeah, that's why. So those things are not initialized. There's no data. Right. So this basically has no data, right? Yet. So it's like a, you know, no data. Okay. So let's go back here. Blah, blah, blah. So that is that. So we have this compute load factor thing, and this will have data later. Okay, just to actually illustrate here some points. So let me, for example, just go to the, I don't know, second object here, and I'm gonna say printf, and I'm gonna say here the pointer, right? So that's basically the address, the memory address of this, right? Where this stuff is stored. Um, and let me just see here. So print memory addresses of slot array. Let me see what's the syntax for that. Ah, okay, not an easy. Well, have to loop and all that stuff. Okay, fine. Yeah, garbage. Yeah, not what I wanted. But anyway, so basically this is that, right? So there's the first memory address here. Let's go, I don't know, to the third one. Uh, that is strange. Not sure. Not sure. Um, but yeah, I don't know. Let me do this. Why not? Copy paste this thing and see. And interesting. Well, I'm not sure why. I'm actually not sure why. Maybe they don't really have memory addresses at the moment. Not sure. Interesting. Okay. I'm just gonna leave that actually for now like that. Yeah. Maybe they get the. So here, for example, yeah. So that is the basically where this array is. It's always like the memory address of the first byte of the array, and then the others will be the individual memory addresses of the others. Okay, fine. So I'm gonna just remove this stuff. Just remove for now. Okay, nice. And I'm just gonna do this. That's it. So they're all nil. Okay, nice. Okay. Okay, so now I have this insert stuff, search. Okay. So I'm gonna now do the insert thing. So actually insert one of these keys. So okay, not sure also why I have the buckets here as an argument. Seems quite weird. Let me see. Ah, okay, I see why. Because when it's resizing, I put the new slots. Okay. Okay, fine. Okay. So I have here my collision count. I think I have to initialize here US64, and then I have here the home location, the first hash. It should be this one. Okay. Okay. Let's put your slots. So right here I created the data thing. So key value, and then is soft deleted. I mean, that could be false, although technically speaking we don't need this. Default value bool. I'm pretty sure it's false. I mean, so for bool, so default value Golang. Yeah, that would be cooler actually. Yeah, false. Of course, quite common. Okay. Why can't it index slots? Okay, fine. Alright, right. Yeah, that's it. And then here we say, oops. Here I say okay, and increment by 1, and here just return. Okay. So what this is doing is like this first, it's basically the home location refers to like the original location. Okay. So it's like the original location of the original hash of this key. So if that equals nil, like if there's nothing in there, basically, we store the value, we increment these counters, and we return. Let's say that's like the base case, so to speak. Then we have here home location does not equal nil, and home location dot key equals key. So we found the thing. So that will basically update the value, right? Value equals value, right? So this basically is updates value. First, element. Okay. Nice. So now we basically will start probing, right? So what that, okay, I'm not gonna go into that in so much detail in this video, but basically what that means is if so let's say this is the slot array. Okay, nice. I don't even know for how long I've been recording. 2:30? I don't know. Does this tell me the length? No, nothing. Not really sure. Okay. So let's say everything here is like empty, right? So let's say it's empty, 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 empty. So let's say our first hash index. I don't know. This is like basically the hash, right? And that determines the index of the array. So let's say there's like, yeah, later we inserted an element, and then say we're inserting another element, and for some reason there's like a hash collision. This will basically start probing, and what that means here, so what that means is that we're gonna calculate a new hash with the collision count until we find basically a slot, right? So that means like if there's some key that has to the same value, we're going to create the hash with the collision count, right? And let's say it now landed, I don't know, here for some reason, here, and it satisfies this condition, right? So nothing is stored there. Then it will store that value there, right? So when we're searching, basically, now when we're gonna search for that, let's say value or key in the future, what will actually happen is that we will first go here, right? Then we'll say, oh, the key does not equal that, so it's gonna be a hash collision. So we also do the probing thing once we search. And then we will go directly here and we say, oh, the key is equal to this one. Yes, it does. So now we found the thing. So that's how basically it resolves all these collisions. But that's kind of rare in hash tables. And then since it's also rare, let's say it's not really common that to search for a value, we have to do like so many hops, right? So it's not going to be like really considered to be linear time search in the vast majority of cases for a hash table. So that's the idea of the probing thing. Nice. So now I'm gonna, of course, increment collision count here, right? Because we know a collision happens, right? Now I have to implement this, which in Golang, it's more of, if I remember correctly, it's like an empty4, right? An empty4, and then here I will do the delta location, and then we're going to go to the hash. Then we have the key, right? And then we have, oops, what is this? Collision count, perfect. So I'm gonna basically do now if delta equals home location, we break, right? We break the loop. We'll break the loop here, and then we do the same Basically, I can copy paste this as well. So I can copy paste this, and there's actually better. Forgot the shortcut actually to copy this thing. There's like a nice shortcut. Now I don't remember. But this is basically the long way, and it's gonna create some problems. But and the format I think is Go FMT. Okay. Okay, fine. So could have also kind of copied this comment as well. Okay, whatever. So here it is. Okay. So that's that, and then we have. You can also actually just copy this. Maybe I can also do some little bit of optimizations here. So, and this is not home location. This is actually delta location. I made some mistakes here. So this is actually should be all delta location. Delta location. Fine. Okay. And basically, if not, we also, if nothing of that is still met, we do increment the collision again. We increment the collision again. Okay. But I actually could only have one collision count. Actually here. Instead of two. Instead of two. So let me do it here at the top. So collision count plus plus. Okay, let's do that for the time being and see. Okay, so that's the insert. That is the insert. And I don't know, I'm gonna try it right now. So fine, and I'm gonna say fmt dot print. Okay, you know what? Let me just go and see the VS Code keyword. Bucket. So the one I'm looking for. Copy, line up or down, Shift Alt. Okay. Yep. Ha, there it is. Cool. Okay. So fine. But I have the private. Okay. No, I can't. Yeah, I can't test it at the moment because I'm actually at the private one. Okay. Cool. So where is the insert here? Okay, so now I'm gonna have, okay, let's make this public one. Okay. So I'm not gonna do the load factor thing at the moment, the resizing. So h dot slots and t and value. Okay. So now let's do this. So I'm gonna say foo again. Foo1 and 40. Why is this complaining? No value used as value. What the hell? What the hell? Ah, so I'm doing something really stupid here. yeah. Of course. Let's do this here. Yep, that's not what I wanted to do. Got a little distracted. Maybe I'm getting hungry. Whew. Whew. Whoops. Go run. There it is. There it is. There it is. Yep. So this is our thing. And maybe if we want to do the following. I don't know, let's call it the item. Put it like that for structs. See, and I'm just gonna 1, 2, 1, 2, and 3. Yep, there's our thing. I'm gonna add new line here so it's clear. So this is the thing here, right? Marquee, value, and is not deleted. False. Perfect. So update it here. Oh my god. Okay, I am getting quite hungry. Quite hungry. Okay, compute load. Compute load factor. Okay, compute load factor. And then we have if load factor is larger than or equal to the resize of threshold, we resize. This thing is resized, and of course there is no resize here at the moment. But it's gonna have slots and key and value. Ooh, wow. Okay. Whew. Okay, so I'm gonna leave it here for the moment. I'm gonna leave it here. And I also don't know for how long I've been recording. So, okay, stop recording. Okay, cool. Now I'm back from eating, which is very helpful. Okay, get back to this. So we were here in the resize. In the resize. Okay. Okay. Into here. Okay. We assign to the new length, the new, I'm going to move new size, new size. Let the slot counter equals 0, and then I think will be the same make. This. Okay. Loop. And I forgot how to do a loop in Golang. Let's see if I mean it's quite verbose, but let's leave it like that. Okay, item. So we say if item is equals nil, or basically continue. Otherwise, we insert. Okay, and then here we assign equals new. Okay. So what we're doing basically here is we're looping through the existing slots. So basically, if one is nil or if it's soft deleted, we basically skip it and just insert the ones that don't have that condition. Basically, the active ones um, into the new basically array. Okay, so resize it should actually be. So in this case, it will be h.length times 2. So we will do double the size. Okay, so that is that. So I think one thing that would be nice to do is to have some unit tests actually. Just to, I think now is a good time instead of just doing the print, the printing. Okay, so I'm gonna clear this. So touch, and I think it's a good time to just close some of this stuff. I'm gonna leave the shortcut here. Well, unit testing. Forgot a little bit of the syntax here. Okay, let's see what this says. And if I ending a file's name with test.go. Okay, so touch test.go. Okay, perfect. Nice. I don't know why it defaults to link. Testing. Well, first of all, let me test this one. Test new, so and then this is T, pointer to testing dot T. Okay, so length, so let's say 10, and then want, let's see. Okay, nice. So let's say target length equals 10. So we're gonna say if does not equal target length, we basically error out, and it says t dot error f. So hash, it's a hash table length equals what should be, and h dot length and target length. Okay. Why is this being complained? Of course. Because of this. Okay. Extra space. Nice. So let's see how this is at the command line in the greetings run go test command. So go, oops, maybe like that probably. Perfect. So that passed. Why is this complaining? Probably should be capital. Yeah. Maybe didn't get it. Perfect. Now I want to make it fail just for the sake of it. Okay. Just to make sure it's getting picked up. Nice. Getting picked up. Cool. Okay, nice. That's it. So, okay, cool. So that is that. I think I'm gonna now test quickly the insert. Test insert. It's gonna be a simple insert. Let's say 10 for the time being. So I'm gonna say key. So key equals We'll do the famous foo1. Insert, and we're going to say key and some value, I don't know, 500 maybe. Nice. So there's one, yeah, that's it. And then, well, I don't have my search function actually. So I can't really test that, or if I do a little cheating. Nah, it's gonna be too much. And then, I know what to do. Active slot counter should be 1. Okay, so let's do that. So hash table dot, and so if does not equal 1, right? T dot arf equals this. Oops. But it should equal 1. Okay. Let's run this again. That passes. Nice. Okay, cool. So that's that. Oops. I'm going to do this. Go to the hash table here. Okay. So I'm going to do now search. So it's quite similar as well. Quite similar. Value any. And again, the collision count. So we have here var collision count UN64. Oops. 64 equals 0. And then we have the famous home location. Collision count, nice. And then I have here item and slots home location. Right, so if item equals nil, we basically return nil, right? So here we will return, can we return? Okay, so there I go. So yeah, it turns out the pointer. So if item does not equal nil and item.key equals key, then we know we found the thing. Oh, and of course, fast delete. I almost forgot this. And is not soft deleted. and it's not soft-deleted. Okay, it's soft-deleted. We return the thing. Item. Cool. Item, actually the value, yeah. We have to return the value. And actually the value is any. Any. And I don't know what would be more idiomatic, if to throw an error or return like nil. I'm not really sure. You can go. Would it be error, maybe? Would I say nil? How do I return an error now? I forgot that. Let me see. Return error from function in Go. Return and handle an error. Yeah. Well, okay, let's do the thing. Why not? The Go style. So let's do the Golang style. The Golang style. Ah, there is errors. Fine. So I could have just actually done this. Oops. So errors dot new. Yeah, key not found, right? Let's say key not found. Key not found. So I think here we can say error. Yep. And then here I return me for the error, classical Golang stuff. Okay. So now here we do the same business. So the same business here. So we get collision count plus plus. Just always like a similar pattern, right? Because we need to search for the thing, so we need to probe again. So probe. And then we do delta location. Collision count, perfect. Slots and delta location. So if item equals nil, we do the same thing here. And there it is. We return nil, fine. Key not found, right? And why is this complaining? Ah, of course, calling if it was a method. Nice. Okay. What's this complaining about? String error should not be capitalized. Fine. I don't know, it's so weird. I don't know why. Who knows why? Okay, now what's it complaining here? Should not end with punctuation or new lines. Okay, that's I don't know why. Some Golang here. Ah, of course. Let me see. Of course, I'm duplicating here this because I have some redundancy in this code, the Python one. Tautological, yeah. So this is redundant, right? Basically delete it. There it is. That's cleaner. Nice. So now I say if item does not equal. No, I don't need that also. If item dot key equals key and item dot is soft deleted is false, of course. Ah, come on. We return the thing, the actual value, and we return need for the error. Otherwise, we increment collision count. Ah, no, sorry. No. We don't increment collision count because it's already incremented above. It's already incremented above. And if nothing of this is, we return the error. Okay. Right, so at the end we return the error. And what's up with this? Unreachable code. Yeah, well, it makes sense actually. I don't need this because, yeah, this is redundant. Yeah, nice. Okay, cool. Okay, nice. So I think let's go here to the test. So now I kind of test the search function here implicitly. So let's say hash table dot search. Let's say the key. So yeah, I made a mistake. So I don't need value here. Okay, nice. So let's see. So if error does not equal nil, okay, so t dot, what would be here? I think this needs to be error. It's like the go thing. Right. Okay, wait a minute. Log of fatal. Not really sure. So let me see if I can do something here. So So empty hash table expected but returned not sure what will be the formatting here. Give key string. Okay, so let's run this thing. So why is error? Ah, wait a minute. So if error or value equals nil, actually. Wait a minute. Let's see. So if item equals nil, we return nil, but errors is not nil. Error declared but not used. Can I? This is strange though. Hmm. Let me see here. Let's say error like this. Mm-hmm. Hmm. Okay. Let's see here. Empty hash required search return nil with key from error key not found. Yeah, but I also want to say if error If error equals does not equal me, that should. Okay. So return with key full error key not found. There it is. So okay, fine. So that's it. I want to see if maybe this can be kind of like wanna do this style maybe. So let's say search. Let's go like this. Search s equals value, right? So equals value, and I think let's keep it like that. Value. I would say want nil. So key. We have key, and then we have value. This needs to go. So there we go. Key value thing. Okay. Okay. So I think that's it. Oops. But actually it makes more sense. Makes more sense to say value here. Right? So search equals the want nil. That's more. I mean, it's gonna output the same, but just from the reading of the code is easier. Okay. Nice. So I think that's it. So everything is, of course, passing, and um, here I can right put this here. And of course, it's complaining. No new variables, so something like that. Error B, not the best thing, but we'll do for the time being. Okay, so now I can basically copy this stuff. Okay. And I will say want. 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 nil. So we have key. So want, yeah. So let's see here, target value. So target value 500. So we have key here, and then target value and error. Okay, let's run it again. Oops, I go run, but go test. Nice. So I guess for the sake of breaking this thing, just to make sure it's running fine. Yep. Okay. Cool. So that's that. I'm gonna go back here. Nice. So that is the search. Implicitly tests. Sorry, that is the test insert. Implicitly test search as well. So not sure. I'm not sure if I should maybe leave that test and maybe as it was before. Okay, testing T. Okay, so I think, yeah, I'm kind of thinking that perhaps I kind of want to do, yeah, kind of want to do this actually. So, yeah, because then it's going to be too redundant, right? Like that. And then, but then, yeah, I have to copy this as well. Okay, like that. And yeah, let's put key again here. Key. Full one. Okay, so search. Nice. And I'm wondering if before that, can I? Okay. Can I do something? Actually, no, this is not gonna work. It's gonna think in cheap. This is inserting it directly in the slot. Let's see. Find insert. And then we're gonna search again. Okay. So I think for this is fine. Doing like that. And doing this. So, oops. So hopefully everything will Yep, nice. Okay, so these are pretty simple ones. So like tests here, we're not like, yeah, trying to think through edge cases yet. So let me go back to hash table here. So we have the search, and then the delete thing is also quite similar pattern. Hash table delete again by key. I think we should also return like an error. Cool. So in this case, the deletion. Okay, I'm pre-computing this before. But okay, maybe I can do it a little bit different. So okay, so the famous collision count here. Collision 64. This is going to be and slots in is going to be home location. Cool. Return new. You can say key not found. Okay, fine. You know what? Let me also kind of for now, it's going to say error message. Not found. Okay. Now if okay, so if item dot key same thing equals key and item dot if self deleted also the same thing. But I don't think this should make sense actually to return an error here because it's not the fault of the of the person or the thing calling this code that if the key is there but has been previously deleted if it doesn't exist. So it should maybe just return a success. Well, not sure. Not 100% sure at the moment. Let's leave it like that. Let's see. And now we go to the following condition if we need to resize down. So I think I can. Okay. So we found the thing, right? So item dot result deleted equals true. Active float counter we decrease by 1. Not that's H, of course. H dot resize and new size. Right. But it's, of course, I need to do a load factor thing. So let me compute the load factor. Resize down threshold. Resize. Nice. And now let's do a new size here. Okay. It's fine. It doesn't matter. It's very quick. So quick operation, that division. So I have to do h.length divided by 2. But let me try something here. Yep, you're in 64. Okay. Fine. Nice. Okay, so here I'm going to return nil. Okay, actually let me do here, this one. Okay, so let me do this test. Casting. Nice, okay. It's gonna this full 1 keys everywhere. Now I'm gonna say right. So if error, you know nil has to be nil now. So okay. Delete. Okay, nice. Let's test this thing. Missing return. Okay. Oh yeah. So here, I'm just gonna return name for the moment. So this should return here need item. So need here should be null. Should not be null. So if nil does not equal nil, sorry, if error does not equal null, we do that. So error. Oops, sorry, yeah, just like that. There it goes. So, okay. Okay, cool. So that's it. So this is passing. Oof, for some reason, I'm getting quite sleepy as well. Okay, so we have the first delete kind of test here. Looks like it's in for the time being. Now it's the same pattern here. So again, so we will go code. Put the location. Okay. So self deleted is false. Okay, the same thing. So I can basically, this could probably be also maybe wrapped into its own method, so to not repeat so much code there. Active slot counter, this has down threshold, and then it resizes the thing. And here we return nil, of course. And then that's it. So that's the last of the deletion. Nice. So we have insert, search, and delete. But I also actually forgot to do these here. Double checking. Probe. Here I am. Boom. Delete. Okay. Okay, nice. So missing return. Okay, I'm gonna do something really quick. So I'm gonna do this key not found error message. Maybe here. Okay. Not found error message. Okay. I have here another one. Nice. Here we found error message. Okay, cool. Now here, return. Let's see the same one as here. So Okay, let's run this again. Nice. Okay, cool. So I think this is already complete here. So one thing, yeah. So basically, yeah, finished all the methods here, like the core methods at least. And just to double check. Now, where did I accidentally put? I changed my. I don't know what key I pressed. Yeah. So, but I changed it to US English. Okay. Yeah, and effectively, this will be like the operation. Yeah, kind of like not so efficient here because it has to loop through everything and assign. It's basically looping through like all the elements on that hash table linearly. So yeah, I'm not sure if that will be very efficient. Anyway, so okay, so let's continue here on the test. So I'm gonna expand this. Here's basically the basic deletion. Nice. So now what I want to do, I think, insert search delete. So maybe create something much more. Test perhaps like test resize up. Testing.t. Nice. So yeah, I mean officially, let's say this is kind of like uh, finished, kind of. But I think I would like to see really like if it's if there's no like errors or something. So right now, these simple unit tests have passed, which is at least a good sign. And yeah, I want to try to hit the resize mechanics here. So if I have the hash table again, let's say 10, right? And the ratio to resize up has to be larger or equal to 60. So that means that inserting 10 elements will trigger the resize, I believe, because will be 10 divided by, sorry, not inserting 10 elements, 7 elements, divided by length. So that should be 0.7, but look, just, of course, just to do the thing here. So we have 7 divided by 10, of course, 0.7. Very obvious, but just throwing in here the calculator. So 7 elements. We need to insert 7 elements. So for that, okay, so let's oops. So for that should be smaller than, it will be 7. Let's say 8. No, yeah, that will be 8 basically. And now we're gonna say hash dot insert the other one, not this one. Hash table dot insert, and then we have the key and the value. So fmt dot I want to return a string. Let's see if this one, No, this one doesn't return a string. Is it sprintf? I think. That's it. Yeah. Sprint formats according. Yeah, cool. So it's going to be, let's do the famous foo, and then d, right? And then I just put like I. Why not? What's this complaining about? Ah, of course. So I. And this could be maybe two. This is differentiated. Okay, so this should resize. So hash table dot length. So wait. So target or expected length actually should be equals, and then maybe just to do some, we have 10, and then expected length equals length times 2. That is expected length. If hash table dot length does not equal expected length. Okay. Wait a minute. 364. This is good like that. T dot error. So hash table length equals, but and then so hash table length and then expected length. Nice. So let's run this thing. Ooh, what happened here? Runtime index out of range. Why index out of range? That is weird. That is strange. That is very weird. Okay. Seems like there is a weird bug here. Whew. There is a strange bug. Okay, so here, let's see what this says. Testing go, blah, blah, blah. testing, blah blah blah, round tag, hash table, line 57. So this is the problem. Huh, interesting. Maybe one thing for maybe just to be safer, Sonny, to be a little safer, let me try something here. Sonny, what happened? Okay. Oh my God, what happened, Sonny? Huh? Enemy bot. Lost my train of thought. Oh yeah, Golang loops. I forgot to do, not to do, but to see. Um, I need to see the range. I could have just looked range for loop. So Golang range loop. I think that's the thing I want. Let me try this. Okay, I think it's H. Let's see if that will. So I don't. Yeah, I think that will basically avoid this thing. Um, or, or. Let me just do this. Actually, let me just do this. Let me do this. Okay, still. So one. What's up with this? Okay. And also what I want to do here is I want to comment this out for the time being to not have like any noise, just to isolate this. Ah, I see what I did. That was okay. So each of them -1. This soft deleted. So this will of course fail here. I mean, I'm just gonna double check. I'll do it here, resize. In slots. So mm, can I do is len a function? No, she's kind of doing it like Python actually. H dot slots is the thing I want. The length of v according to its type. So let me check now. Okay, that yeah. So that was yeah, that was a little stupid. So okay, nice. So it works. Of course, I was doing h dot length -1, which is not good because here I'm assigning the new length, and of course it's going to be an index out of range. And then here I insert in the new slots. Boom, boom. Yeah. Okay. So nice. So of course there I'm computing the new, right? So when we're computing new, that's something important. New hashes for the keys, right? But every existing element will have, of course, a new hash value. Okay, so that is that. So I'm gonna uncomment this stuff now. Forgot to uncomment this. FMT imported but not used. Classical error here. Nice. Cool. So some live debugging section now here, which is good. It makes it more interesting and exciting here under pressure, and actually also with feeling a little sleepy as well. That I think I should stop this thing also soon. Nice. Okay, so we have the expected length, right? So it's 20. We know that. Okay. So now I'm gonna func test resize down. That's what I'm gonna test at the moment. Okay, cool. And I'm gonna do actually the same. I'm gonna do the same. Steal this stuff here. Okay, nice. So resize down. So this will be divided by 2. So okay, this resize down is a little different. So I want to format this thing. Okay, cool. And active slot counter, occupied slot So if it's just occupied, so with the occupied it has to be 0. So let's see if there's 0.12. So 2 divided by 10. 0.12, right? 5 divided by 10 will be 0.5, of course. That'll be 0.1. Zero point 0.1. Okay, nice. So basically what needs to happen is that I will insert two things. So, okay, I'm just gonna steal this thing here. So I'm gonna insert two stuff, so 0 and 1, would be 2. And then I'm gonna delete one of them. So hash table dot delete foo is gonna be foo 0. It's gonna be foo 0. Okay. So let's run it. Whoops. Okay, nice. Nice. So fast as expected. So I'm just gonna make it break here for a moment. Yep, that's it. You see 5. So it's resized down nicely. That's good. Whew. Okay. So, whew, I don't know how much I've been recording. I forgot as well to look. Whew, 7. Maybe like an hour and something. I'm not sure. But okay, I'm gonna do the last thing. The last. So I want to kind of. There's something. Okay, so I have these two things, so occupied and active slot counter. So one thing maybe I can test here, which that I haven't done as well, is test this. Active and occupied should be the same right when I'm when we're resizing up. And it should be 8, right? So I'm just gonna put this total items. Okay, I'm still gonna run this thing. Okay, perfect. So now when I say like if hash table dot active slot counter should be 7, because I haven't inserted more. Fine, let's cast it to uint. Who cares for the time being? No, it does not equal actually. It does not equal. So I should say t.error. So hash table active slot counter equals expected. Okay, let's run this. Okay. And let's see this. Occupied slot counter should also be the same. Okay, occupied slot counter equals 13, but expected 7. Let me see. Maybe if I am actually insert here, okay, fine. Wait a minute. So resize. Okay, so I think I know. So I'm not saying actually occupied because essentially it needs to be reset every time because it's a new array. This has to be reset, and then we count again. So when this is inserted, so occupied, and active. I think that's yeah. So I think that should fix it. Nice, that's it. So this is actually one of the examples why unit tests are so important because right, you can easily overlook like I forgot to reset the occupied slot counter here to 0, right, like some naive mistake probably because I'm here like yapping along, but then that could cause a serious issue because we're not keeping track of things accordingly. And then we would, for example, in this case, need to like resize up much more often, which of course will be a great performance hit. Nice. So that is they're covered. So so this thing here is covered for resize up, and it should also I mean, it will be kind of redundant for resize down as well. Or maybe not. No, I think it will be different. So let me. So So this should be 1. So expected size, let's say size, or expected total items. Okay. Okay, interesting. This is weird actually. I would expect only because there should be one here. There should be one here. So do I have FMT here? FMT dot print print a line, and then I'm gonna print this thing. So hash table dot slots. 1, 2, 3, 4, and 5. Okay. So before this, see what it is. Oh, yeah, small. Well, yeah, that's why it was actually wrong. Okay. Mm, so this is after deletion. Yeah. So I have something wrong here, probably in the way I'm setting up the test. Um, 'let's see, delete, region count on location, etc. Active slot counter. Zero and one. Yeah, so it's 2 divided by length smaller than 0.12. So yeah, I mean this should be like this. Yeah, sorry, I was using the wrong factor. So yeah, here is only one, right? Smaller than, so it's one, so it should be full, like full zero here. Then it's this thing after deletion, which is 5. And of course, it should be empty actually. Yeah, so yeah, it's like this actually. So it should be empty. Okay, nice. Oof. Nice. So I think that is it for the moment. Um, would be nice to do, I think, for next part. So just gonna set it up so a bit more like a life cycle kind of thing. Just maybe end to end. Let's call it E to E. Okay. And I'm gonna uncomment all this crap and run this thing again. Oops. Nice. Okay, nice. So this is it for today. It's getting quite late. It's Sunday. So yeah, I think it was a pretty good session. Nice. So I hope everybody enjoyed this. Um, yeah, I'll keep doing a last part for this. That's going to be, I think, a little shorter. And well, maybe I'll also would be interesting to do the stress testing, and at the same time see like how efficient, if this array of pointers to those data structs has an implication on the performance of the thing. So yeah, let's see. So yeah, thanks for tuning in, whoever did. Have a good day or night. See you.